So we will solve an equation here. You can see we have three equations, and these equations can be solved by naive Gauss elimination. Simply what we need to do is first, so this is the pivot element, then we need to eliminate this x1 from the second and the third equations. For the second one, we need to divide 0.1 by 3 and multiply the first equation by that. So simply we will do this 0.1 divided by 3 and multiply it by this. Then what we will have is simply 0.1 x1 here minus 0.1 times 0.1 divided by 3 x2 minus 0.1 times 0.2 divided by 3 x3 is equivalent to 7.85 times 0.1 divided by 3. And if we actually write these, subtract these from the second equation, from this, simply the first ones will be eliminated. Then the second one will be simply from here. This is a very small number, so if we subtract this from 7, actually it's summation, so it becomes 7.00333 x2 minus here 0.3 and this one, so we subtract this, but there is negative, so it will be summation, and this is negative, that's why 0.293333. we need to be careful about round of error, so that's why we need to have many numbers like this, and this will be equivalent to minus 19.5617. so we subtract from this, actually subtract this from this one, so that's why it's minus and this value. Next we will do this division and multiplication of the first term for the to eliminate the first term of the third equation. So that's why we need to use 0.3. And in here, instead of this, now we will divide by 0.3 by 3 and multiply it by this. Then we will have and subtract this. So let's first multiply and see the result. So when we multiply it, we will have 0.3 x1 minus 0.1 times 0.3 divided by 3 minus 0.2 times 0.3 divided by 3 is equivalent to 7.85 times 0.3 divided by 3. So this is the first equation. We subtract this from third equation. If we subtract this from third equation, you can see that we will have an elimination of the first terms. Then, so this, starting from the second term, we will have minus 0.2 minus 0.1 times 0.3 divided by 3. Simply this will give us minus 0.19 x2. For x3, here we have 10 minus, actually these are x2 and x3, I forgot to write these, minus this value, so it will be plus 10.02 x3 is equivalent to, here we have 71.4 and minus this value, which gives 7.6150. So now we have three equations. The first one is the same, this equation. The second one is this with the elimination of x1, and the third one is this with the elimination of x1 again. So let me write these down. Simply 3x1 minus 0.1 x2 minus 0.2 x3 is equivalent to 7.85. And the second equation is 7.00333 x2 minus 0.29333 3x3 is equivalent to minus 19.5617, and the third one is minus 0.19x2 plus 10.02x3 is equivalent to 7t.6150. Now here we have started to obtain the upper triangular system. In the first equation we have x1, in the second we have x2 as the first element, and in the third one we need to have x3 as the first element. So we need to eliminate this. To eliminate this, then we will actually divide and multiply. Divide minus 0.19, the first term of this last equation or the third equation, by the first term of this equation, 7.00333, and multiply this by the second equation so that we can have an elimination of x2 from the third one. So multiply this here. I will not write the results, but multiply and subtract this, from third equation. Then the third equation becomes, basically, we can write this way. So this one was eliminated. Then the second one here is actually subtracted from this, multiplied by this, which gives us 10.0120x3 is equivalent to this subtracted from this multiplied by this, and it gives us 7.0843. This is the third equation now. So simply we will have this equation as the third row here, and that's why we will have just one unknown here, so that we can start from here for back substitution. If we simply isolate x3 here, we will find 7.0843 divided by 10.0120 is equivalent to 7. Simply. Then back substitute this. Substitute into second equation, meaning here. Then from this one we will have (7.00333) minus 0.29333 times 7 is x3 is equivalent to minus 19.5617. So that from here x2 is equivalent to minus 2.5. We found this as well, and this one. Now we back substitute these. Substitute into first equation. So here, take this and put it here, and x3 into here. Then the third equation becomes, let me write here, 3x1 minus 0.1 times minus 2.5 minus 0.2 times 7 is equivalent to 7.85, and finally from here x1 is equivalent to 3. So we found all of these simply, and so x1 is 3, x2 is minus 2.5, and x3 is 7, and we simply verify the result by putting these into the first equations here. Here substitute these 3 into here, and here, to be able to have the same result of these or not. If you have the same results, then the results are correct. If not, maybe you have a mistake during the operation, because we have many operations here. You can go back to the operations and see where the problem is. So simply you can have a final verification. Verify by using these in the original equations. Of course, by using these in the original equations, you need to find these final results and compare these with the original results. Finally, we are done with this.